Good afternoon, everyone. Today, I am going to present my topic on digital voting system, an important application of digital electronics that plays a major role in modern democracy. As we all know, voting is the backbone of democratic country. It allows citizens to choose their leaders and participate in decision making. Earlier, it was done using paper ballots. Although simple, this method had many drawbacks, such as slow counting, chances of human error, invalid notes, and many more. To overcome these issues, technology has introduced digital voting machines which make the process faster, more accurate, and more secure. What is a digital voting machine? It is an electronic system designed to record, store, and count votes digitally. Instead of writing on paper, the voter simply presses a button corresponding to their chosen candidate. The machine then records the vote and updates the total count automatically. So the system works on a simple digital flow: input to processing to storage to output. This reduces manual work and improves efficiency. What is the need for digital voting machine? Now let's understand why we need such a system. In traditional voting, counting takes several hours or even days. Human mistakes can occur. Invalid notes increase. Large amount of paper is used. This machine can solve all these problems by providing instant and fast results, ensuring accuracy in counting, eliminating invalid notes, and reducing cost and environmental impact. The objectives of the system. The system is designed with some important objectives. One person, one vote, which means no duplicate voting. Accurate counting, which means every vote is counted correctly. Transparency, means the results are clearly displayed. Reliability, system should work without failure. This ensures fairness in elections. Basic components. Let's understand how the system is structured. First, input section. Push buttons for each candidate. Interface used by the voter. Second is processing section, which involves control unit and logic circuits. Third, storage section. It includes counters and flip-flops. Fourth, output section. There is a display unit. Fifth is a power supply, provides energy to the system. So overall flow is voter input goes to control logic to counter and then it displays the output. Concepts used. This system is based on core digital electronics concept. Logic gates, these are basic building blocks. They decide whether the input is valid or not. Flip-flops, these are memory elements that store data temporarily. They help in maintaining system stability. Counters, these are sequential circuits that count the number of votes. Each valid input increases the count by one. Debouncing circuits, these remove unwanted noise from switches and ensure only one signal is counted per press. These together work to make the system efficient. Working principle. Now let's see how the system works step by step. The voter presses a button for a candidate. Second, the signal goes in the control unit. Third, system checks whether the input is valid or not. Fourth, if valid, the counter increases by one. Fifth, the updated count is displayed. This happens in milliseconds, making the system very fast. Push button and debouncing. When a mechanical button is pressed, it does not produce a clean signal. Instead, it creates multiple small signals due to vibrations. This is called bouncing. If not handled properly, one press can be counted multiple times. To solve this, we use debouncing circuit. This ensures one press equal to one vote. Logic gate operation. If one button is pressed, vote is accepted. If multiple buttons are pressed, then the vote is rejected. This is done using logic circuits that detect invalid combinations. Flip-flops in voting machine. These are used to store the state of system. They help in holding temporary data, maintaining stable signals, and avoiding fluctuations. Counter circuit. These are very important in this system. Each candidate has a separate counter. Whenever a valid vote is received, the counter increases by 1. These can be binary counters or decade counters. They ensure accurate vote tallying. Display unit. The display unit shows the result. It can be a 7-segment display or an LCD display. It shows number of votes clearly, so results are easy to understand. Control unit functions. The control unit is the brain of the system. Its functions includes enabling voting, allowing only one vote per person, disabling input after one vote, and resetting the system. This ensures proper operation of the machine. Truth table. This follows a logic rule. Only one button, valid vote. No button, no vote. Multiple buttons, invalid vote. This is implemented using logic gates and ensures correct input validation. Advantages. Fast counting, high accuracy, no invalid votes, easy to operate, and a reliable system. Applications. It is used in government elections, college elections, surveying and polling, small organization votings. Its limitations are it needs continuous power supply, requires strong security, it requires higher initial costs. The feature improvements that are required by the system are adding biometric authentication, using IoT for monitoring, implementing data encryption, making it more secure and portable. To conclude, digital voting machines are a modern and efficient solution for conducting elections. They reduce errors, save time, and provide accurate results. With future improvements, they can become even more secure and widely used. Thank you.